Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment Omnis in short videos of a few minutes. In this video, I will show you how to create a basic unstructured mesh. Let's say that you have imported a geometry into Omnis, in this case a volute. The geometry does not have holes bigger than the cell size we will use. We are ready to start the meshing. So let's move on to the domain context. In the domain context, locate the pie at the bottom of the window. If you don't see the pie, click on the little arrow at the bottom of the screen. Click on the first button, Create Domain. Use the plus symbol to create a new domain. You can rename it here if you'd like. Then, select the geometry entities forming the closed body and add them to the domain. Apply and close when you're done. You should now see the geometry entities as well as 3 intersecting black lines. Let me change the volute visibility so we can see these lines better. Let's right-click on the volute assembly, rendering options, and let's make the surfaces transparent with no lines. Now you can see the point at the intersection of these 3 lines. This is the seed point from which the mesh generation will be started. This seed point should be inside the domain to mesh and not too close to the boundaries. You can move it by dragging the dots at the end of the black lines. You can also enter the seed point location by clicking on seed point in the tree and entering its coordinates. We can also change the boundary conditions of each patch in this context. So let's expand the tree, change the inlet patch to an inlet boundary and the outlet patch to an outlet boundary. Once all this is specified, we can move on to the mesh context. Once again, locate the pie at the bottom of the screen and click on the first button, Create Mesh Setup. Click on the plus symbol to create a new mesh setup and rename it if you'd like. You can choose the meshing technique from the drop-down menu. We will use HexPress to generate an unstructured mesh. Select the domain on the left-hand side and add it to the setup. Then apply and close. A mesh setup is created. Depending on what you have selected in the tree, you will see different menus in the property window at the bottom. Let's start by selecting the mesh setup. We want to create a volume mesh and we want hexahedral elements instead of mixed elements. The initial cell size will be the largest cell size in your domain. You can see that the mesh preview is adapted as you change this number. Refinements can be added on the whole assembly or on specific boundaries. For example, you might want to have a smaller cell size on the inlet patch. Let's expand the tree to see all the boundaries, select the inlet, activate the uniform surface refinement, and add one refinement. You can see the effect of this local refinement on the mesh preview. You can also modify the diffusion level, which indicates how many neighboring cells will be affected by that refinement. However, you will not see the effect of the diffusion on the grid preview. Let's talk about the other 2 refinement criteria using the volute walls. I can select both boundaries by holding the Control key. The auto edge proximity will add refinements when 2 edges are close to each other. You can impose a minimum cell size under which the mesher will not refine. The curvature option will add refinements to achieve the imposed number of divisions, here 4, on a 90-degree sector of a sphere. By increasing the number of divisions, the mesh on curved surfaces will be finer and the meshed surfaces will appear smoother. Let's also add some viscous layers on the walls. Let's choose the inflation method, which will inflate the buffer layer before inserting the viscous layers. You can set the first cell size, in this case 110 to the minus 4, the stretching ratio from layer to layer, and either a fixed or a floating number of layers. By using floating, you give the mesher some freedom to adapt the number of layers to obtain a smooth expansion ratio. When you're ready to start meshing, go back to the mesh setup, click on Control, change the parallel settings using the antenna symbol, and click on Start. Once the mesh has been created, you can check the mesh quality using the Mesh Quality button in the pie. The window summarizes the CPU time and mesh quality for all mesh setups in the tree. To analyze the mesh further, load it by clicking on the Load Results button of the control panel or the plot symbol next to the mesh setup. After the mesh is loaded, you can create cutting planes and visualize the volume mesh on them by activating the wireframe visibility option. Finally, you can create cell ranges by quality criteria. For example, if we wanted to check where skewed cells are located, we could create a cell range between 0.8 and the maximum skewness. Click on Compute and show the cell's location to find out where they are. To see them better, let's hide the cutting plane using the symbols on the left of its name. And let's make the volute transparent once again by right-clicking on it on the tree, rendering option, and activate the transparency and remove the mesh. Now we can see where the skewed cells are located. When you are done with the mesh analysis, unload the mesh to avoid slowing down the Omnis interface. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.